Bismillahirrahmanirrahim. Dear students, today's our topic is laws of chemical combination. I first of all hope that all of you are fine and doing well in your studies. These laws of chemical combination, they govern the formation of chemical compounds from different elements. Let us take this reaction: hydrogen gas that reacts with chlorine gas, leading to formation of this gas, hydrogen chloride. Hydrogen chloride is the gas formed within the reaction in between hydrogen and chlorine. Now, according to laws of chemical combination, what is the mass of this that combines with a fixed mass of this? After that, what is the mass of this hydrogen chloride gas formed? If I will take it as fixed volume, now what is the volume of this gas that combines with its fixed volume, and what is the volume of this gas that is formed during the reaction? After that, if I will take it as number of molecules, suppose its number of molecules are 100. Now what is the number of molecules of this gas they will mix with 100 molecules of this gas? What is the number of molecules of this gas they will be formed during the reaction? The experimental investigations carried out by various scientists, by many scientists in the 18th century and in early 19th century led to formation of laws of chemical combination. These are the laws, they govern the formation of chemical compounds. These are the basic laws. Here I have written 6 laws, but in our textbook this law is not written. So these 5 laws are the basic laws of chemical combination. First of all, we know this one, law of conservation of mass, put forwarded by Antoine Lavoisier in 1789. After that, this one, law of definite composition, or we may call it law of definite proportions by mass. This given by Joseph Proust in 1779. After that, this one, law of multiple proportions. This law put forwarded by John Dalton in 1803. Law combining gaseous volumes. We know this one, put forwarded by Gay Lussac in 1809. Avogadro's law, Emilio Avogadro put forwarded this important law. After that, this one, law of reciprocal proportions. This one put forwarded by Richter in 1792. These are the basic laws by means of which we can explain why elements combine leading to formation of chemical compounds, what is the formula of those chemical compounds, why a chemical compound. For example, if I will take water, why water obtained from all sources, from different sources, that is having this formula, means within that formula there are 2 hydrogen atoms and 1 oxygen atom. The answer to these questions is present within these laws of chemical combination. Law of conservation of mass. This law states that in a chemical reaction, these are the various statements by means of which we can state this law of conservation of mass. In a chemical reaction or in any physical process, mass of reactants is equal to mass of products. So, within a chemical reaction, there is not any detectable, not any, even a small, not detectable change in mass during the reaction. Means within the process, within a chemical reaction, if the mass of reactants is measured and after the completion of reaction, mass of products is measured, that mass is equal. Means there is not any detectable loss or gain. Detectable loss or gain of mass during a chemical reaction. This one can be also used as a statement of this law of conservation of energy. After that, we can say this one, matter, or even you may say mass can neither be created nor destroyed. Matter can not be created or cannot be destroyed. can neither be matter, can neither be created nor destroyed. So this one is also statement of law of conservation of mass. After that, if we have a reaction, that reaction occurs in a way such that that one is incomplete, means that reaction not goes to completion, then within that reaction mass of reactant is equal to mass of products plus this one mass of unreacted reactants, means those reactants their mass which have not reacted within that reaction, then they if combined with their mass measured with the mass of products, then this sum is equal to this sum. After that, we know in case of nuclear reactions there is mass loss, then that mass loss we know that is converted into energy. After that, if that mass loss, that means it is energy equivalent if that taken with the mass of products, then mass of products plus the energy released within that reaction, that is again equal to mass of reactants. These are the some ways by means of which we can state this law of conservation of mass. For example, here I will take this one, H2 plus Cl2. They react with each other, leading to formation of this HCl. If mass of this one is 2 gram, means 2 gram, here mass of this, that we know it is molar mass, that is equal to 35.5 multiplied by 2. Then the total mass on this side is equal to 2 plus this one 71. Then this is equal to 73. After that, here if I will balance the reaction, then here will be 2. The mass of HCl molecule, that is equal to 1 plus 35.5. So multiplied by 2, that is again equal to 73. Now on the product side there are 73 grams, and on the reactant side there are also 73 grams. Means within this reaction, mass on reactant side that is equal to mass on product side. So there is conservation of mass. There is not any kind of mass loss or mass gain during this reaction. Now let us take this example. If I will say this one calcium carbonate upon heating, this one leads to formation of calcium oxide, then this one carbon dioxide gas is released. Suppose carbon dioxide formed within this reaction, that is equal to 4.4 gram. Now if it is 10 gram if taken, what is the mass of this one produced during this reaction? Suppose I will take its mass equal to X. Then we know according to this law, mass of products is equal to mass of reactant. So here I will write X plus 4.4, that is equal to mass of reactants, means that is equal to 10 gram. So X is equal to 10 minus 4.4. Now X is equal to, we know this one 10.0, now this one 4.4. After that 10 minus 4, that is equal to 6. Now here 9 minus 4, that is 5. So the mass of products, means calcium oxide, that is equal to 5.6 gram, because 5.6 plus 4.4, that is now equal to 10 gram. So within this reaction we have calculated, if this one is given and this one is given, we have calculated the mass of this one by means of applying this law, means law of conservation of mass. Within this reaction again we will say that mass of reactants, that is equal to mass of product. This law of conservation of mass, that was tested by Landolt in a tube that we call as Landolt's tube. I will take simply this tube just like this one is the tube having two tubes. They are joined with each other in this way. This one sealed and this one also sealed. Within this tube I will take the aqueous solution of sodium chloride. So this one is here within this tube. After that, within this tube I will take this one, silver nitrate. It is aqueous solution. Now if they are allowed to react, that means if we will tilt the tube, then they will mix with each other, and the reaction that occurs, that will be NaCl aqueous that reacts with silver nitrate solution, leading to formation of this one, AgCl. We know precipitate is formed. It is the precipitation reaction. I can say here this one as solid. After that, this one sodium nitrate. This one present in the solution. That means this one. Now before he measured the mass before the reaction of these two reactants, means the content within the tube plus the mass of the tube. Now after tilting, they mixed with each other, they formed this product, and after that the mass of the tube were also measured. It was found that the mass of products again that is equal to mass of reactant. Now this law of definite composition, law of definite proportion, this law put forward by Joseph Proust when he was working on a sample, that on a chemical compound, that chemical compound is cupric nitrate. Obtained from natural origin, means natural source. Natural origin, this compound obtained by means of synthetic way. Then the percentage of the elements which are present within this, they are copper, they are nitrogen and oxygen. Their percentage of copper, I will write here this one, percentage of nitrogen and percentage of oxygen. The percentage of copper, this wire 51.35, and percentage of 9.74. Percentage of oxygen, that were 38.91. When the same compound observed in terms of percentage of copper and oxygen,
nitrogen,
in this synthetic sample also, synthetic sample of cupric nitrate, that was again 51.35. After that, this one 9.74, and this one 38.91. From this experimental observation, he formulated that whatever may be the source of, whatever may be the origin of a chemical compound, the percentage of elements within that compound, that is again always same. I will take here the example of water obtained from different sources. For example, these are the sources, some of the sources, say rainwater. After that, this one river water, this one even tap water, even we may say, for example, water obtained from our river, say Hindus call that Ganga Jal, this one. It is always, whatever may be the source, or we may obtain it in a synthetic way, synthetic method, by means of which we can obtain water. Then water is always having this formula, within this we can say if there are 2 grams of hydrogen, they always will mix with 16 gram of oxygen. Means combination of oxygen and hydrogen within this molecule is fixed. Whatever may be the source, whether that is the natural source or of natural origin, or that one may be the synthetic, that is having the masses of elements within this, they are always fixed. Here I will take this one, 1 gram will react with, here I will take 8 grams. So in 9 gram of water, there are always 8 gram of oxygen and 1 gram of hydrogen. So this one hydrogen and this one oxygen. Or I may say just like this, in 16 plus 2 means 18 gram of water. 18 gram of water, there are always 16 gram of oxygen and 2 gram of hydrogen. So whatever may be the source for obtaining any chemical compound, the percentage by mass of the elements present within that compound, that is always fixed. So this one is the law of definite composition. Means a compound is having definite composition. Means that not varies, or definite proportion. Means in terms of mass, elements combined in terms of a fixed ratio. That ratio not varies from the method of preparation, whether that is of natural origin or that method of preparation is the synthetic one. The masses of the combined elements within that compound, that is always fixed. Law of multiple proportions put forwarded by John Dalton. The statement of this law: when 2 elements combine with each other, leading to formation of more than 1 compound, then the masses of one element that combines with the fixed mass of other element, they are always in the ratio of small whole numbers. For example, I will take this statement and illustrate this statement by means of these examples. For example, we have sulfur and oxygen. They combine with each other, leading to formation of this compound, sulfur trioxide and this sulfur dioxide, this one. If we will take the mass of one element within these 2 compounds, that we take as fixed. For example, taking the mass of sulfur as fixed, equal to 32 gram. Now here also mass of sulfur equal to 32 gram. After that, the mass of this oxygen atom that combines with this one, that is equal to 48 gram. Now within this, mass of oxygen that combines with the fixed mass of sulfur, that is equal to 32 gram, because we know atomic mass of oxygen, that is equal to 16, and 16 into 2, that is equal to 32. Now this one is the fixed mass of sulfur within these 2 compounds, that is fixed. Now we will take the ratio of this and this, that means 48 is to 32. This one is equal to 3 is to 2. 3 is to 2. So within this ratio is a ratio of small numbers. This ratio of whole numbers, simple ratio. So this law, again I will state this by means of this example. When 2 elements combine with each other, leading to formation of more than 1 compound, then this element the ratio of the masses of this element with the fixed mass of this element, they are always simple whole numbers. The ratio is a simple whole number ratio. Now let us take this example, nitrogen and hydrogen. They will combine with each other, leading to formation of this compound, NH3, after that this one, N2H4. Now taking the mass of this one, nitrogen as fixed. So within this, taking that equal to 14 gram. After that we know within this mass of hydrogen, that is equal to 3 gram. Within this compound, mass of nitrogen is equal to 28 gram. So mass of hydrogen, that is 4 gram. Now with the fixed mass means dividing this by 2, that is equal to 14 gram, and this one will be equal to 2 gram. Taking this one as fixed, mass of nitrogen as fixed, equal to 14 gram. After that, dividing the masses of hydrogen atoms within these two compounds which have combined with the fixed mass of nitrogen, that is equal to 3:2. That is a simple whole number ratio. Now after that, taking this example, third example, suppose nitrogen and oxygen, they will react with each other. We know nitrogen and oxygen, they react with each other, leading to formation of different oxides. 5 oxides, they are this one, N2O, after that this one, NO, after that I will say this one, N2O3, this one, N2O4, and this one as N2O5. These are the 5 oxides of nitrogen. When nitrogen and oxygen, they react with each other. Within this, we can say nitrogen 28, oxygen, that is 16. After that, here nitrogen 14, oxygen 16. Within this one, nitrogen 28, oxygen 48. And within this nitrogen, that is equal to 28, and this one, oxygen, 16 into 4, that means that is equal to 64. And within this nitrogen 28, and this one equal to 80. So taking mass of nitrogen as fixed, let us take that equal to 14. So this one, 14 gram of nitrogen, 14 gram of nitrogen as fixed. Then we know here with 14 gram, there will be now 8 grams of this. With 14 gram of nitrogen, there are 16 grams. With 14 gram, means with divided by 2, there will be 24 grams. With here 14 gram, there will be 32 grams of oxygen. Now within this, with 14 gram, there will be 40 grams of oxygen. So ratio with the fixed mass of nitrogen, the ratio of oxygen atoms within these compounds, that is equal to 8 within this and 16 within this. After that, here 24, and after that within this one 32, and within this, that is equal to 40. So this ratio is simply 1:3:4:5. Each one dividing by 8 gives us this ratio, and this ratio is the smallest, simplest whole number ratio. Gay-Lussac's law of gaseous volumes. Gay-Lussac carried out experiments on gaseous reactions. Within those gaseous reactions, he formulated a law. That law we call as Gay-Lussac's law of gaseous volume. Statement of this law: when gases react with each other, however, under similar conditions of temperature and pressure, at fixed T and P, temperature and pressure, when gases react with each other, the ratio of volumes in which they react with each other, that ratio is the small whole number ratio. For example, I will take this one to illustrate this law, hydrogen and chlorine. Again, hydrogen and chlorine gases, they react with each other, leading to formation of this one, hydrogen chloride. This one in gaseous state. The reactant gases, they react with each other in terms of volume. For example, it is one volume and it is one volume. So the ratio is 1:1. That is a small whole number ratio, leading to formation of this product even if we carry the division, the ratio with the products also. But the products must be in the gaseous state. Then these reactants in the ratio in between the reacting gases as well as with the products, that is a small whole number ratio. So within this we can say this one hydrogen. If we will take hydrogen as one volume, suppose this one is one volume, after that with it will react one volume of chlorine. Here the products, they will be formed, their volumes will be, the number will be equal to 2 volumes. So 1 volume of hydrogen, 1 volume of chlorine, they react with each other, leading to formation of 2 volumes of hydrogen chloride. If I will take its volume as 1 liter, it is 1 liter with react with it is 1 liter, the products, they will be formed, their volume will be equal to 2 liters. Or I may take it is 50 ml, then after that it is 50 ml will react with 50 ml of hydrogen gas, then the volume of this, that is 2 times more than this, that is 100 ml will be formed. Now taking this next example, this one second, nitrogen and hydrogen, they react with each other, leading to formation of this gas NH3. They are all in the gaseous state, reactants as well as products. Balancing this reaction, so I will write here 2 and here 3. So with 1 volume of nitrogen, 3 volumes of hydrogen will react and 2 volumes of NH3 will be formed. In them, the ratio 1:3 is a small whole number ratio. So with 1 liter of nitrogen, 3 liters of hydrogen will react and the products, they will be equal to 2 liters. Or I may take this one with 50 ml of nitrogen, there will react 150 ml means 3 volumes. Now 100 ml of ammonia will be formed. If I will now take the numerical problem just like this. For example, these two gases, they react with each other. If we have taken it as 40 ml, what is the volume of chlorine required to react with 40 ml of hydrogen? What is the volume of HCl produced within this? Now according to this, we know 1:1 is there. So if there are, it is 40 ml, then 40 ml of this will react with this. And its volume formed is equal to 2 times, because here 2 volumes are produced. So that will be equal to 80 ml. We call this law as law of gaseous volumes, or this is the law of definite proportion by volume, because within this we have taken volume. That volume, when gases combine, leading to formation of products, then they combine in terms of volumes in a fixed, in a definite way. That is why we can call this law as law of definite proportion by volume. The first one, Prost's law, we call as law of definite proportions by mass. The scientist Emilio Avogadro make use of Gay-Lussac's law in order to put forward a simple but significant generalization. That generalization we call as Avogadro's law. This is the statement of this law. Equal volumes of all gases, one of the ways, equal volumes of all gases, or I may say different gases under similar conditions of temperature and pressure contain equal number of molecules. Contain equal number of molecules. Again I will state equal volumes of different gases, or the gases which we will take in our observation under similar conditions of temperature and pressure, they contain equal number of molecules. Let us take this example. Suppose we have one volume of this hydrogen gas. One volume of hydrogen gas, then after that this chlorine, it is one volume also, leading to formation of this gas, hydrogen chloride. This one, we know it is two volumes they are formed. If we will take the three gases under similar conditions of temperature and pressure, means we will keep temperature constant. Let us take temperature equal to 0 degree centigrade. After that, pressure is equal to 1 bar. Then it is one volume, it is one volume, and it is one volume. They will contain equal number of molecules. Equal number of molecules. Or you may say, if we will take 1 liter of this gas, 1 liter of hydrogen, after that 1 liter of chlorine gas, after that 1 liter of this one hydrogen chloride gas, under similar conditions of pressure and temperature, within this 1 liter of each gas, there will be equal number of molecules. Now, taking the general one, this one, we know under these conditions, means temperature 0 degree centigrade, pressure 1 bar. If we will take molar volume, means molar volume, we already know that contains 6.022 into 10 raised to power 23 molecules. At that time, volume occupied by this gas, that is equal to 22.4 liter. After that, volume occupied by 1 mole of this gas, that is again equal to 22.4 liter. Volume occupied by this gas, it is 1 mole, that is again equal to 22.4 liter. So here equal volume means taken equal to 22.4 liters of each gas. Now within them there is equal number of molecules, and that number is Avogadro's number. This Avogadro's law formed a foundation for the development of kinetic molecular theory of gases. This one, kinetic molecular theory of gases. After that, it gave us the method by means of we can determine the molar mass of gases. So molar mass, or what is molar volume, etc., that can be determined by means of this law. Even this law, if we have two gases and their molar mass is known to us, then we can compare their densities. A rational explanation for Gay-Lussac's law now lies within Avogadro's law. This law put forward by this scientist. According to this law, if we have two elements, suppose those elements, they are A and B, they combine with each other, and even these two separately combine with the third element C. If its mass is taken as fixed, so the ratio of the masses of these two elements which combine with the fixed mass of this element is either same, I will write here, is either same or the simple multiple of the ratio in which they combine with each other. Again, I will state, if we have two elements, they combine with each other, and even both of them they combine with the third element, forming compounds with the third element. The ratio of the masses of these two elements with the fixed mass of these will be either same or will be the simple multiple of the ratio of the masses in which they combine with each other. Now let us taking this example. For example, we will take this one, carbon, oxygen and hydrogen. These two, they will react with each other, and even carbon will react with hydrogen, oxygen also reacts with hydrogen. I will take this in this way. There are three elements, suppose carbon, oxygen and hydrogen. Carbon and hydrogen, when they react with each other, they form methane. After that, hydrogen and oxygen, when they react with each other, they will form this water molecule. After that, carbon and oxygen, when they will react with each other, they will form this compound. So these two elements, they separately combined with this element, forming their respective compounds. Now within them, within this reaction, we now know 12 gram of carbon will react with 4 gram of hydrogen. Then methane will be formed. Its mass will be 12 plus 4 means 16. Now in case of this, here 12 gram, again 12 gram of carbon that reacts with 32 gram of oxygen, then carbon dioxide is formed. In this way, hydrogen reacts with oxygen. Its mass is 2 gram. Now the mass of oxygen within this, as per formula, that is 16 gram. Taking the mass of this one as fixed, let us take that one as 4 gram. So its mass is now 4 gram. With 4 gram, it is 12 gram reactor. Means carbon 12 gram reacts with 4 gram of hydrogen. So now here with 2 gram, we know 16 gram they react with 2 grams of hydrogen. If we will take it as fixed, that we have taken equal to 4 gram. So with 4 gram, this one multiplied by 2 and this one also multiplied by 2. That means 32 gram. Now the ratio in which these two elements, carbon and oxygen, they combined with fixed mass of hydrogen, that ratio is equal to 12 is to 32, or I may write here oxygen is to carbon. Then they reacted with fixed mass of hydrogen that we have taken equal to 4 gram. The mass of this one reacted, that is equal to 32. After that, this one, its mass equal to 12. This ratio is equal to now 4 8s are, after that this 4 3s are 12, or in this way it may be equal to 3 is to 8. So this ratio. Now we will take the ratio of the masses in which they combined with each other. That is again equal to here. If I will take first oxygen, then after that carbon. So its mass is 32 gram here, 32 gram, and its mass is 12 gram. That is again equal to this 32 is to 12, and that is equal to 8 is to 3. That is the same. Again, I will state this law in this way. If two elements separately combine with a fixed mass of third element, then the ratio of the masses in which they combine with the fixed mass of third element, that is either same or simple multiple of the ratio in which they combine with each other. Now taking this example, combination of nitrogen. Suppose they combine with fixed mass of hydrogen, nitrogen and oxygen. We will take here again this one as fixed hydrogen, this as nitrogen, and this one as oxygen. When these two will react with each other, they will form a oxide. Suppose that oxide is N2O3. When these two will react with each other, they will form this NH3. After that, this one and this one, they will react with each other, leading to formation of water. Now, within this compound, we know one nitrogen atom means 14 gram. They will react with here 3 hydrogen atoms means 3 gram. After that, within this reaction, H2 means 2 gram. After that, oxygen, that means 16 gram. Now, within this reaction, N2, that means 28 gram. After that, oxygen, that is equal to 16 into 3, that is 48 gram. Now, making this one as fixed, here 3 gram, here 2 gram. So multiplying these two with each other, then the number 6 will be obtained. That will be then formed from this side also this side. Means taking the fixed mass as 6 gram. 6 gram. So in this way I have multiplied 3 by 2. That means then here are 3 gram. Now instead of 3 gram we have taken 6. So multiplying 3 by 2, that gives 14 into 2, that gives 28. Now in the same way, here I have taken 2 gram. Now equal to fixed as 6 gram, means I have multiplied it by 3. So I will multiply this one also by 3, that is equal to 48 gram. After that, this one, this and this, their ratio. First of all, we will take this ratio. Now here 28 gram of nitrogen. They react with 6 gram of hydrogen. 6 gram of hydrogen. In this case, we have now taken as 48 gram of oxygen. 48 gram of oxygen that reacted with, again this one as fixed, 6 gram of hydrogen. Now the ratio of the masses in which these two elements combine with each other also with its fixed mass. First of all, we will take the ratio in which these two elements combined with the fixed mass of this element, hydrogen. That is equal to 28 is to this one, 48. Now the ratio in which they combined with each other, that is again equal to 28 is to 48. So we will take this one as 4 7s are 28. Now after that, this one equal to 12, and within this also the ratio is equal to 7 is to 12. So I have taken 2 examples. In these 2 examples, within this nitrogen and oxygen, they combined with each other, and even they combined with hydrogen. In case of reacting with hydrogen, with its fixed mass, the ratio in which they combined with the fixed mass of this element, that ratio is either same or the simple multiple of the ratio in which they combined with each other. These were the laws of chemical combination.